Now we have the integer overflow and underflow vulnerability. This is a common error in Rust and it also cascades to surrounding programs. We all know that an overflow happens when a number goes past its maximum value and wraps around. Then an underflow happens when a number goes below zero and wraps to a very large value. We have this here, 100 minus 200. In Rust, it gives you this amount, 18 quintillion. And we are aware that any subtraction or addition in Rust without the checked arithmetic, if wrongly done, could amount in a number that does not break the program. The program keeps going. We have this instruction, this withdraw instruction here, that withdraws a particular amount from the user. Let's assume we have no check, checking if the amount being requested for is in the account or the account has up to that amount. We just go ahead to withdraw a certain amount from the user's balance. Now, doing 100 minus 200 gives you this, which causes an overflow, giving you 18 quintillion. So how do we mitigate and how do we avoid this error? Brings us to checked arithmetic. In Rust, we use checked sub, checked addition, checked add. You see them in the Rust script. They are used to perform checked arithmetic, ensuring that if there's an underflow, the program returns a none. Then that none now you can chain it into an um, insufficient font error, which then can go on. This is exactly how we mitigate this. So the takeaway here is that never use raw arithmetic operators for financial calculations. Ensure you're making use of checked arithmetic using checked sub instead of just subtracting the regular way. You can check this out on the playground to see how it looks like. Now this is the integer overflow. To use this, we simply register user's ledger account here. Now the user has an account registered. We first of all we deposit, then we try to withdraw a big amount, bigger than what we have deposited. See our balance of 0.1, so but we're trying to withdraw 0.2. Let's see what happens. Hold on, click withdraw. Now you see what happens. The internal ledger balance becomes 118 quintillion as we said. So with this now, this is the new user balance. So the user now can keep withdrawing and withdrawing till he exhausts the liquidity here. Let me show you what I mean. If I withdraw again now, remember the account has changed to 18 quintillion now. So the user can keep withdrawing 0.2 and to just make a small change in the amount here. If you withdraw again, you see the user keeps getting credited 0.62 and is actually removing this from the liquidity. The user has enough balance to go around. So no matter how much lamport you take out, if I withdraw again, it keeps going that way, that way. And you can see this actually gets reduced. If you notice, see the change here. Actually gets reduced, meaning that you can keep withdrawing till you exhaust this 1.3 soul that is in the total liquidity, which makes this a vulnerability for this application. If you try out the secure part, let's see how it works. We have to let's register the user's account first. Now we have 2 soul as the liquidity balance here, and then let's try to deposit first. We deposit as a user. Now we are free to withdraw. We have a balance of 0.1 soul, and we go ahead to withdraw. You can already see fail in the simulation. Now you see withdrawal failed. You see this error here. Blocked. Checked arithmetic prevented underflow. Simple. So with this secure version, we cannot exploit the program via that means anymore compared to the vulnerable version. So ensure at all times you use checked arithmetic to avoid issues with integer overflow or underflow.